Hi, welcome to Virtual CB1A. This is Miss Rena, and we are already in the third chapter of our elementary statistics textbook. So, this is chapter 3. Our focus is on describing, exploring, and comparing data. So, there are three topics under this chapter. First is measure of center. Second, we have measures of variation. And finally, measures of relative standing and box plots. For the first two topics that we have here, measures of center tsaka measures of variation, meron na tayong um, video discussion na naipost sa Google Classroom. But still, I will discuss some important parts na na-mention dito sa book para meron tayong stress dun sa mga ma-stress natin yung mga importanteng properties ng mga measures of center tsaka measures of dispersion or variation even without looking at the other video. Kasi baka hindi nyo gustong panoorin lahat ng mga video na presented sa cumulative review. So, as usual, we are going to start with the chapter problem. So, this chapter problem is all about the airport data speeds. So, which carrier has the fastest smartphone data speed at airports? So, dito, meron tayong 50 na different US airports na ginamit for our sample. And the data set can be found on Appendix B. If I fast forward ko na siya, let's move to figure 3-1. So, yung mga importanteng parts na lang yung i-highlight natin. So, for figure 3-1, out of the 4 service providers, if you will analyze visually yung mga box plots natin, these are stacked on top of one another. Which one do you think has the best speed? Let's start with T-Mobile. So, ang pinakang peak niya ay about, nandito, sa siguro mga 5 Mbps to. So, most of the data points are in 0 to 10. So, medyo mababa siya. So, AT&T, that is between around 2 to 12 siguro. And then for Sprint, ito, sobrang baba ng speed niya. So, mga ano lang to, siguro, mga 0 to 5 Mbps. But for Verizon, kalat siya. And some of the data points are even over 60. Ayan, may mga ano data points tayo na over 50 Mbps, over 60 Mbps. And yung mga peak niya, yung pinakamararaming data points niya, these are distributed from 10 to 30. So by visually analyzing this graph, we can say that Verizon performed the best out of the 4 network providers. Sila yung may fastest na speed in megabits per second. Now, let's talk about the chapter objectives. Starting with the measures of center. Ganun pa rin tayo, we are not just after the computation or the value. More than that, kailangan nating matuto kung paano mag-analyze at mag-interpret. So first, we have measures of center. You are expected to develop the ability to measure the center of data by finding the mean, median, mode, and mid-range. On the video, given on your cumulative review, meron dong process ng pagkuha ng mean, median, at mode. At saka process ng pagkuha ng mean, median, and mode manually and by use of Excel. For mid-range naman, ito hindi ko to naisama before kasi hindi ko siya sinama kasi hindi naman siya usually ginagamit and ibang subject yung tinuturo ko before, hindi elementary statistics. But this time, since we are focusing on elementary statistics alone, i-define na rin natin kung ano si mid-range. And then, determine whether an outlier has a substantial effect on the mean and median. For the second topic, we're going to focus on measures of variation. You are expected to develop the ability to measure variation in a set of sample data by finding values of the range, variance, and standard deviation. And also develop the ability to interpret values of the standard deviation by applying the range rule of thumb to determine whether a particular value is significantly low or significantly high. Sa measures of variation, dun sa dati nating mga videos, makikita nyo na rin dun kung paano mag-compute ng range at standard deviation. So, si variance, nadadaanan siya ng procedure ng pagkuha ng standard deviation. So, kahit hindi ko to binigyan ng focus before, makukuha to basta marunong kang kumuha ng standard deviation pag manual. Pero kung meron kang Excel software or any statistical software or instant calculator, you can also get the value of variance and standard deviation instantly kahit hindi ka na magmano-mano. And finally, we have measures of relative standing and box plots. Ito hindi ko to ginawa ng video before kasi ang focus lang namin dun sa isang sa statistics class ay measures of center and variation, hindi itong standing or location. So, develop the ability to compute a z-score and use the result to determine whether a given value x is significantly low or significantly high. I am not sure if the standard scores were presented to you nung nag-GE 114 tayo kasi medyo blurry na yung yung memory ko about our GE 114 class. I think na discuss ko to dun sa um, previous year before kayo. Pero dun sa inyo, hindi ko na talaga matandaan kung kasali to sa mga na-discuss ko before. Next, we have identify percentile values and quartile values from a set of data. When we say percentile, this is 100. This corresponds to the number 100 and quartile corresponds to the value 4. Okay, so division by 5, division by 100 at division by 4 lang tayo. And next, we have to develop the ability to construct a box plot from a set of data. So, let's start with the measures of center. Hindi ko ipapakita kung paano mag-Excel. Kung gusto nyo malaman kung paano gumamit ng Excel application, just check out the other video. I will put the link on the description box later. So, part 1, basic concepts of measure of center. So, in part 1 of this section, we introduce the mean, median, mode, and mid-range as different measures of center. Measures of center are widely used to provide representative values that summarize datasets. So, itong mga measure of center na to, ito yung mga statistics that we expect to give reliable representations for the whole population. So, yung mga sample statistic natin dito ng center, dapat clearly mare-represent niya kung ano talaga yung behavior ng buong population. So, how can we make sure that our center is a valid representation? So, meron tayo ditong mga important properties. Isa-isahin natin siya later. So, pagka sinabi natin measure of center, it is a value at the center or middle of a dataset. So, gitna lang ang hinahanap natin. There are different approaches for measuring the center. Let's begin with the mean. This is also called arithmetic mean and kilala rin siya sa tawag na average. So the mean or arithmetic mean of a set of data is the measure of center found by adding all the data values and dividing the total by the number of data values. So ang gagamitin lang natin ditong operation ay addition at saka division. Kailan natin gagamitin si mean? Kailan siya valid na representation or valid na statistic, reliable na statistic? So, sample means drawn from the same population tend to vary less than other measures of center. So, halimbawa, meron kang 20 na members ng population and then you randomly select, ay gawin na lang natin 10. Ayan, halimbawa, meron tayong student 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ayan. And then, we are going to choose about 4 samples out of these 10 students. Halimbawa, unang pagra-random sample mo, sample 1, Ang nakuha mo ay si 1, 3, 4, at 10. Sample dataset 2, ang nakuha mo ay si 5, si 7, si 6, at si 8. Tapos, si sample 3, ang nakuha mo ay si 2, 3, 9, at 10. And then, syempre, napakarami mo pang possible na combinations ng sample dito. 'Di ba? Sobrang dami. May formula rin tayo dun pero hindi ko na-discuss. I think, na-discuss natin yun before sa history. Combinations and permutations. So, sample 1, kung kukunin mo yung average nito or yung mean nito, ang mean ng sample 1, hindi siya greatly magva-vary sa mean ng sample 2 at sa mean ng sample 3. Pag i-compare mo yan, halos magkakadikit lang din sila. Yun yung property ng mean. Sample means drawn from the same population tend to vary less than the other measures of center. Next, the mean of a dataset uses every data value. So, kapag ka kumukuha ka ng mean, gagamitin mo lahat ng value present on your set or set of sample o kaya lahat ng data value present on your population. Kasi may dalawang klase tayo ng mean. Sample mean at saka population mean. Pag sample mean, this is taken from a sample, and syempre kapag ka population mean, taken from a population. So you have to remember that. Pag kumukuha ka ng mean, wala kang iniiwan na value sa sample, o kaya wala kang iniiwan na value sa population. Ano ang disadvantage ng mean? Kailan siya hindi dapat ginagamit? So, when you have outliers, bakit? Kasi sensitive siya sa outlier. Meron tayong proper na term dito. Yun yung term na resistant. Pag ang isang measure of center ay hindi affected ng outlier, that means it is resistant. Pero si mean, hindi siya resistant. Pagka meron kang outlier, greatly affected si mean. So, sensitive talaga siya sa outlier. So, kapag may outlier ka, I suggest don't use the mean. Your statistic will not be a valid representation of your dataset. So, a statistic is resistant if the presence of extreme values or outliers that cause it to change very much. Now, dun tayo sa notations, yung mga ginagamit natin na symbol sa pagkuha ng mean. So, you have to be familiar, hindi lang sa pagkuha ng mean, pero sa pagkuha rin ng iba pang statistics dito sa symbol na to. This is the Greek letter sigma. Capital siya, uppercase sigma. This means summation of, or it is the sum of. Sa formula natin, summation of x, it means sum of all the data values present in your sample o kaya on your population. And then si n, kapag ka lowercase n siya, ibig sabihin sample size. Pero kapag ka malaking n na yan, ibig sabihin population size. Pagka kumukuha tayo ng sample mean, meron tayong ginagamit na notation or symbol. Ito siya. So, si x bar. This is pronounced as x bar. If the data of the entire population is the one being taken, ang ginagamit naman natin na symbol ay ito. Para siyang M na U, pinagsama. Kaya ang tawag sa kanya ay mu. Okay. Now, let's, lowercase siya ha, maliit na letter mu siya. Notation. Ito ay the sum of all the set of values. And then si x is the variable or isang data point, isang value sa ating dataset. Si n ay number of samples. Si capital N ay number of data in your population. Tapos si summation of x over lowercase n ay sample mean. Tapos si summation of x over capital N ay population mean or mu. So, gawa tayo ng example. Meron tayo ditong 1, 2, 3, 4, 5. Meron tayo ditong 5 data points that represents the data speeds for Verizon. Paano natin kukunin yung mean nila? So, i-add mo lang sila lahat. So, 38.5 plus 55.6, 22.4, 14.1, 23.1. You will end up with 153.7. Pagkatapos mo silang i-add, i-divide mo sila sa dami nila. So, meron tayong isa, dalawa, tatlo, apat, lima. So, divided by 5. So, 153.7 divided by 5, the average speed is 30.74 Mbps. So the mean of the first 5 Verizon data is 30.74 Mbps. Okay, so dito meron tayong caution ulit. Kapag sinabing find the average, we always assume that we are asked to get the mean, 'di ba? But in statistics, when you use the term average, you are being asked to present the center or to get the center. So it doesn't necessarily mean that you are going to get the mean. So average does not necessarily mean mean. Nasusundan ba? Ulit, kapag ka average, hindi ibig sabihin laging kukunin si mean. Pwede rin ang ibig sabihin niya, get the average, find the center. Pwedeng ang ipahanap sa'yo ay median, midrange, o kaya mode. It doesn't necessarily mean mean. Okay? Okay. Now let's talk about the median. So the median can be thought of loosely as middle value in the sense that about half of the values in the set are less than the median and half are greater than the median. So dito ang hinahanap lang natin ay gitna, literally gitna. Hindi katulad ng ng mean kanina na sum of all divided by number of observation. Ito, maghahanay ka talaga, tapos literally hahanapin mo kung sino yung located sa gitna. So definition, the mean of the data set is the measure of center, that is the middle value, when the original data values are arranged in order of increasing or decreasing magnitude. So important properties of the mean. The median does not change by large amounts when we include just a few extreme values. So the median is not a resistant measure of center. So hindi siya kasing sensitive ni mean. Si median, kapag ka meron ka dyang mangilan-ngilang outliers, okay lang, hindi siya masyadong apektado. Hindi siya sensitive. The median does not directly use every data value. For example, if the largest value is changed to a much larger value, the median does not change. So, hindi kasi talaga maarte si median. Okay, now, how do we calculate the median? And what is the notation that we use for the median? Kanina, meron tayong X bar. 'Di ba? Okay, sorry, may nag-message. So, I had to reply. Balik tayo dun sa lesson. So, calculation and notation of the median. So, the median of a sample is sometimes denoted by this symbol. So, para siyang merong curve dun sa taas, yung ginagamit natin for the similar to sa math. So, this is pronounced as X tilde or capital M, pwede nyo rin gamitin, or med. Pwede siyang X sub M o kaya X sub med. Pag may nakita kayong ganon, lagay tayo dito ng isa pang sheet. Ito ay median. Ito ay median din. Ito ay median din. Ayan. Marami tayong mga notations na ginagamit sa median. Kung gusto niyo makasigurado, sulat niyo na lang. Median. Pwede rin naman yan. Okay? So, for finding the median, ang unang-una nating dapat ginagawa ay pagsosort or pag-a-arrange. Paano sila ina-arrange? Pwedeng mataas, pababa, or descending. Pwede rin namang mababa, pataas, or ascending. And also, meron tayong process na susundin. Iba kasi ang pagkuha ng median pagka-add ang number ng iyong dataset at kapag ka even ang iyong number of samples. So, paano sila kinukuha? Dito, pag ganito kaunti yung iyong number of samples, it is easy to locate the mean. Kasi madali lang siyang i-arrange, madali ring hanapin yung gitna. Pag tinignan mo dito, 14.1, 22.4, 23.1, 38.5, 55.6. Ang gitna niya, 23.1. Ang daling i-identify. But what if you have a lot of uh, data points or data values? Halimbawa, 100 na sila. 'Di ba ang hirap? O kaya 101 na sila. 'Di ba ang hirap mag-identify, hala, saan ko kukunin yung gitna? So, meron tayong formula na pwedeng gamitin. Ano yung formula na pwede natin gamitin? This is also included on the video that I've posted before. But if you don't want to visit that video or watch that video, lagyan natin siya dito ng maliit na discussion. So, sa median, hindi mo talaga kinukuha kaagad yung number. Ang hinahanap mo ay yung location. For example, the kth observation or the location of your median. Dito, meron kang number of samples na 5, di ba? So, kung meron kang odd number of observation, this is odd, hindi siya perfectly divisible by 2. Ang gagawin mo lang ay gagamitin itong formula for the kth observation. So, the kth observation is in n plus 1 over 2. So, sample natin yung kanina natin. Paano natin nalaman na pangatlo yung kanyang median? So, the kth observation is 5 plus 1 over 2, which is 6 over 2, which is 3, or the third observation. Ito ang location ng ating median. Check natin ulit yung ating example. Una, pangalawa, pangatlo. First, second, third. So, this is our median, yung gitna. So, kapag ka meron kayong sobrang daming observation, magandang maggamit ng ganitong formula so that you can easily identify the location of your median. Hindi yung nagtitingin kayo na, parang ito yung gitna. Hindi ganon. So, i-compute nyo kung nasan yung location using that formula. Again, paano siya naging gitna? Kasi meron kang equal na number ng samples below it at above it. Meron kang dalawa sa ilalim, meron kang dalawa sa taas. Ngayon, paano kung meron kang even number of observation? Meron kang 1, 2, 3, 4, 5, 6. Take note, ito ay sorted na ha. Mula dito, 38.5, 55.6, 22.4, 14.1, 23.1, and 24.5 na napakagulo pa, hindi pa siya magkakasunod, inayos siya ng ganito, ascending. Mula mababa, pataas. Paano kung meron kang even? You have to take note that when you have even number of samples, you will end up with 2 locations. Kasi hindi yan katulad nitong odd na equal yung number ng observation sa taas at saka equal yung number ng observation sa baba. Pag even ang number ng observations mo, dalawa ang magiging gitna mo dyan. So, meron tayong... Barahin natin siya. We have Kate sub 1 and Kate sub 2. Ayan. Dalawa yung hahanapin natin gitna. This is n over 2 at saka n over 2 plus 1. Itong bagong example natin, meron tayong 6, which is even. Diba? So, meron kang 6, 6 divided by 2. You are actually looking for the third observation. And aside from that, you have 6 over 2 plus 1, or the 3 plus 1, the fourth observation. So, pangatlo at pang-apat ang hinahanap natin dito sa ating set of values. So, 1, 2, 3, 4, 5, 6. 1, 2, 3, 23.1. Fourth is 24.5. Hindi pa natatapos dyan. Kung meron kang dalawang gitna, hindi mo pwedeng sabihin na ito yung median 1, ito yung median 2. Ang gagawin mo, kukunin mo yung average nung dalawang gitna. So, 23. 23.1 plus 24.5 divided by 2, you will end up with 47.6 divided by 2 or 23.80 Mbps. So, sana maliwanag yung aking pagkaka-explain. If you have any questions, kindly send me a message. Next, we have the mode. For the mode, ang maganda dito, hindi siya limited with just numerical values. Okay lang kahit hindi numbers ang iyong data. Si mean at saka si median, required yan. Dapat numerical, may value. Pero kapag ka mode, pero pag mode, pwede kahit nominal o kaya ordinal. Okay? So the mode of a dataset is the values that occurs with the greatest frequency. Ito ay paramihan lang. Kung sino yung pinakamaraming beses nag-appear dun sa iyong dataset, siya ang mode. Important properties of the mode can be found with qualitative data, and a dataset can have no mode or one mode or multiple modes. How do we find the mode? Magtali ka lang. Kung sino yung pinakamaraming beses lumabas, siya na yun. Pero kung gusto mong mapadali yung paghahanap ng iyong mean, median, and mode, watch the video with the link in the description box. Nandun yung instant na paghahanap ng mid-median mode using Excel. Anong tawag natin pag may dalawa kang mode? Dalawa yung nag-tie na pinakamataas. Bimodal yon. Paano kung more than 3? Or, yan, 3 or more. So, multimodal ang tawag mo dun sa iyong dataset. Paano kung walang lumamang? Pantay-pantay sila, tigigisa lang. O kaya lahat sila tigdadalawa. So, wala kang most frequently occurring observation, then your set of observation has no mode. And when you have ice cream with your pie, it is called ala mode. This is just a joke. I don't know why the authors included this. Kala nila funny, hindi naman. So, let's go to example for the mode. Meron tayong 2, 4, 6, 7 observations. 0.2 occurred once. 0.3, isa, dalawa, tatlo. Tatlong beses siya lumabas. 0.6, dalawang beses lumabas. At si 1.2 ay isang beses lang lumabas. So, sino yung pinakamaraming beses lumabas? 0.3. Kasi tatlong beses siyang nag-occur. So, the mode is 0.3. So, in example mode, the mode is a single value. Here are other possible circumstances. For example, your data speeds are 0.3, 0.3, 0.6, 4.0, and 4.0. If you will take notice, 0.3 occurred twice and 4.0 occurred twice as well. So, this is a bimodal dataset. We have 0.3 Mbps as your first mode and the second mode is 4.0 Mbps. Paano pag no mode? Ito yung isang example. 0.3, 1.1, 2.4, 4.0, 5.0. Walang lumamang. Isang beses lang sila nag-exist. So, this distribution has no mode. Kasi no value was repeated. Ayan, last na tayo. We have the mid-range. So, another measure of center is the mid-range. Mid-range, this is very easy to get. Very easy to obtain, very easy to compute. All you have to do is to find the maximum value, find the minimum value, add the two together, and then get their average. So, divide mo lang siya by 2. The formula is maximum data value plus minimum data value divided by 2. Important properties of the mid-range. Mas madali siyang i-compute kumpara dun sa dalawa. Kasi ito pang quantitative din siya. Ang mga, again ha, ang mga quantitative natin ay mean, median, at mid-range. Ang pwede lang sa qualitative ay si mode. And si mode, pwede rin siyang maging quantitative. Mean, median, mode, mid-range, pwedeng quantitative, qualitative, wala kang choice, mode lang yan. Compared with the other three, pinakamadaling hanapin si mid-range. And in practice, the mid-range is rarely used, but it has three redeeming features. First, the mid-range is very easy to compute. Again, yan. Ay, ito pala. Nagkamali pala ako ng basa. Unang important property pala ng mid-range natin, just like the median, this is not resistant. Just like the mean, this is not resistant. Pagka meron kang outlier, mamumove ang iyong mid-range. Mahihila siya pataas o mahihila siya pababa. The mid-range is very easy to compute. The mid-range helps reinforce the very important point that there are several different ways to define the center of a dataset, and the value of the mid-range is sometimes used incorrectly for the median. So, to avoid confusion, if you are going to present the mid-range, you also have to present the median. By practice, ganun yung ginagawa para maiwasan yung pagkalito. So, this is an example for the mid-range. This is our data set: 38.5, 55.6, 22.4, 14.1, and 23.1. Ang maximum natin, pinakamataas, is 55.6 at ang ating minimum, pinakamababa, is 14.1. If you add them up, we have 796. 69.7. And 69.7 divided by 2 is 34.85 Mbps. Now, rounding measures of center. When rounding measures of center, we often need to round the results. So, ang tatandaan nyo dito, kapag ang iyong center ay mean, median, at mid-range, carry one more decimal place than is present in the original set of values. Halimbawa, ang set of values mo ay rounded off to the nearest tens lang. Your final answer, okay lang na mag to the nearest hundreds ka. Kasi nangyayari yun, especially when you are getting the average. Ang mga ginagamitan natin ng average ay hindi lang mean, ha? Nagkukuha rin tayo ng average sa median kasi minsan dalawa ang median. So, possibly, madagdagan ng isang decimal place pa yung makukuha mong center when you get the median. And sa mid-range, ganun din. Kung meron kang, katulad nito, to the nearest, ano lang to, di ba? To the nearest tenths lang. 55.6, one decimal place after the period. Pero pagdating din sa final answer, meron kang two decimal places, 85. So, remember, when you are rounding off values, pag magpe-present ka ng numbers for the measures of center, magdagdag ka ng isang decimal place for the mean, median, and mid-range. Okay? For the mode, wala. Huwag kang magdagdag ng kahit na ano. Kasi si mode, as is yun. Kung ano yung nakita mong pinakamataas na pinakamaraming beses nag-occur, siya na yun, di ba? So, no need to perform rounding off. Okay, critical thinking. Critical thinking and measures of center. Ito ay nagtatanong kung bakit hindi mo pwedeng gamitin si mean at si median. So, maglagay tayo ng ibang instances. Siyempre, gawin natin siyang local kasi ito ay sa states. Ang mga zip codes ng mga landmarks natin dito ay 63102, 2500, 2330. Pero ang mga zip codes naman, lahat yan numbers, pati yung dito sa Paite, dito sa local, Philippines. Paite is 4016, Pakil is 4017, Pangil is 401, hindi pala, 4016, 4017, ang Pakil, Pangil ay 4018, Siniloan ay 4019. Sila ay naka-number. But that doesn't mean that they are quantitative type of data. Kasi hindi naman ibig sabihin na si Paite ay 4,018. Hindi, meaningless. Meaningless yung 4016 na to. Kasi hindi naman to value ni Paite. Zip code lang siya. Ibig sabihin, label lang siya ni Paite. This serves as a name or label for Paite, and so are the other values: 4017, 4018, 4019. These are just labels for the geographic location. Magkakasunod yan. Geographic location of the towns. Ganon din dito. So, geographic locations lang siya, labels. So, these are qualitative. So, you cannot use the mean, the median, and also the mid-range. Next, ranks. Ito ay rank number 2 or second, third, 7th, 10th, and 14th. Kapag ka presented ka with ordinal type of data or anything that is ranked, pinagsusunod-sunod, hindi rin siya pwedeng gamitan ng mean at saka ng median. For example, yung first year, second year, third year, fourth year, kasi meaningless din yung quantitative value niya. Sila ay nagsaserve as labels lang din or names. Okay? Ano pa? Number sa jersey. Hindi tayo limited lang dun sa example dito ha. Sa iba't ibang sports, ganito yon. Pag meron ka nakitang number sa jersey, hindi ibig sabihin number ng goals or number ng points, number ng bolang na i-shoot, walang ganon. Kapag ka nakakita ka ng number sa jersey, ibig sabihin label lang din siya ng player. Hindi siya, wala siyang quantitative meaning. Okay? Ganon din dito sa iba. Hindi ko na i-discuss yung D at E. Basically, parehas lang naman yung sinasabi nila. Ayan. Dito tayo sa table 3-1. Magko-compare na tayo ng smartphone, data speeds, Mbps at airports. Ang presented na lang dito ay yung summary. Pero kung gusto nyo siyang i-compute isa-isa, since bibigyan ko naman kayo ng copy nitong book na ginagamit natin, punta kayo sa Appendix B. Tapos tingnan nyo yung dataset na original para dito. May 50 na data points yon or values yon. Kung gusto nyo siyang i-match dito, okay lang. So, for Verizon, i-analyze natin yung mga values ni Verizon. Si Verizon ay may mean na 17.60. Ang median niya tumaas, 13.90. Ang mode niya is 40, hindi pala. Ang median niya ay bumaba, 13.90. Medyo mataas yung variation nila, di ba? Ang mode niya ay mababa, 45.5, tsaka 11.1, meaning this is the usual. And ang mid-range nyo, ang taas, 39.30. So, i-analyze natin. Di ba si mean at saka si mid-range, these are both not resistant to outliers. So, si Verizon, most probably, may outliers dyan. Kaya nahatak pataas yung value ni mean at saka ni mid-range. But since si median, it is very resistant, it is not affected by outliers, ang pinapresent niya is 13.90 lang, which is a bit lower than the mean and significantly lower than the mid-range. Tapos si mode naman, ito ay based lang din sa experience. So, pinakamaraming beses na nag-exist sila, which is almost negligible. Most of the time, di natin ito ginagamit. Okay, ganun din sa iba. Hindi ko na siya hindi ko na siya i-discuss. Ito, part 2 na tayo. Kung meron kang measure of center for individual data set, pwede ka rin kumuha ng measure of center sa mga values na nakagrupo. Yung, di ba, nag-discuss tayo ng frequency distribution before? Meron tayong class 1, class 2, class 3, class 4. So, dito, paano ka maghahanap ng mean for a frequency distribution? So first, multiply each frequency and class midpoint, then add the product. So itong F, ito yung frequency. Si X is the class midpoint. And then, i-divide mo siya by the total number of your samples or total number of your data points. Maglagay tayo ng isang example. Tandaan niyo pa ba kung paano kumuha ng midpoint? So, ang ginagawa natin dito pagkuha ng midpoint is lower class limit plus upper class limit divided by 2. So, bakit naging 99.5? Ang ating class midpoint for the first class. Kuha lang nga tayo ng calculator. We have 75 plus 124. It is 199. Divide mo siya by 2. You have 99.5. Para naman dito, 149.5. That is 125 plus 174. That is 299 divided by 2. 149.5. Okay, so it is suggested that when you are looking for the mean of a frequency distribution, you extend your frequency distribution table. Usually, ito lang dalawa yung pinapakita natin, di ba? Kung maglalagay ka ng relative frequency, madadagdagan lang to ng percent dito sa tabi. So, yung class natin, syempre, ito yung mga classes. These are the times in seconds. Next, yung frequency, kung ilang beses nag-appear yung mga value inside 75 and 124. Ilang beses nag-appear yung mga values inside 125 and 174. At kung ilang beses nag-appear yung mga values dun sa mga natitira pang classes. Syempre, si midpoint, tinuro ko na kung paano siya kunin. Mag-extend ka. I-extend mo si F, i-extend mo yung F multiplied by X. Ano to? 11 times 99.5. I-try nyo, kuha kayong calculator. 11 times 99.5. That is 1,094.5. Check natin yung pangalawa. 24 times 149.5. Okay, that is 3,588. But may point zero dito para uniform na lahat sila nasa tenths. Next, 10 times 199.5. You have 1,995. Next, we have 3 times 249.5. We have 748.5. And finally, we have 2 times 299.5. We have 599. Ano yung susunod natin gagawin? I-add nyo lang to lahat. Ito yung summation of F times X. So, we have 1094.5. Ito yung unang-una. Plus, yung pangalawa, 3588. Ay, plus, yung pangatlo, 1995. Plus, yung pang-apat, 748.5. Tapos yung pang-lima, yung 599. Okay, you will end up with 8,025. Ano yung susunod natin na gagawin? According to the formula, i-divide mo lang sila by the total number of observations. The total number of observations ay 50. So, divide it by 50. So, your frequency distribution mean is 160.5. I hope that was clear. May isa pa tayong klase. Meron naman tayong weighted mean. Nangyayari to kapag ka merong observation na nauulit. Okay? Or, ayan. Ito ang example natin. Pag-compute ng grade point average, ganito rin yung pag-compute ng G1 nyo. General weighted average. Pag nanghihingi kayo sa registrar ng GWA, ito yung ginagamit na formula. This has something to do with the number of units. Dito naman sa ating example, this is the number of credits. Use the number of credit. In her first semester of college, a student of the author took 5 courses. Her final grades along with the number of credits for each course were A, 3 credits. A, 4 credits. B, 3 credits. C, 3 credits. And F, 1 credit. Ang grading system natin dito ay hindi katulad ng grading system natin dito na 1, 1.1, 1.2, 1.3. Ang ibig sabihin sa kanila ng A ay 4. Ang ibig sabihin ng B ay 3. Ang ibig sabihin ng C ay 2. At ang ibig sabihin ng D ay 1. At ang F ay 0. Kawawa naman. So, ang mga nakuha niyang grade, dalawang A. Isang A na 3 credits. Halimbawa, ang subject niya ay English. Nakakuha siya ng A sa English. And 3 units yung English subject niya. Tapos nakakuha rin siya ng A sa 4 units na subject. Halimbawa, ito ay Seminar in Mathematics, 4 units siya. So, dalawa, yung nakuha niyang 4 points, and one is 3 units, and the other is 4 units. Okay? Sana maliwanag. And paano natin kukunin yung weighted mean? So, use the numbers of credits as weights. So, ang weight nila ay 3, 1, at saka 4. So, yun yung mga weights natin. 3, 4, 3, 3, 1. Replace the letter grades A, B, C, F with their corresponding quality points. So, ang excess natin ay 4, 4, 3, 2, 0. Now, we use the formula to pair them up. So, si A, ang kanyang weight ay 3. So, 3 times yung kanyang grade, which is 4. So, 3 times 4 plus 4, we have, ito, 4 units, tapos ang grade niya ay A, which is 4 din. So, 4 times 4. Next, meron tayong B. Ang weight ni B ay 3. Tapos, 3 units or 3 credits din. So, 3 times 3. Next, 3 units ulit. Tapos, nakuha niyang grade is C, which is corresponding to the number 2. So, 3 times 2. And finally, meron siyang 1 credit lang, 1. Tapos, ang F ay 0. So, we have 1 times 0. After that, you have to add all the weights. So, the sum of all the weights, we have 3 plus 4 plus 3 plus 3 plus 1. And overall, you will have 43 over 14, which is 3.7. This is her GWA, or grade point average. Okay? So, ito, meron tayong um, example dito ng mga pwede nyong makuha na output when you use different software and ano pa ba? Software and calculator, Texas Instrument 83, 84, at saka application, Excel. Ayan. Meron tayong Excel stat add-in. Okay, so um, meron akong isa pang i-upload. Yung susunod na topic natin, which is the measure of variation. So, ito muna yung magiging ending nung nung discussion natin for this topic. And then, please wait. Pasensya na, naghahabol tayo ng video lecture. Please wait for the next topic. Okay, thank you. Bye!